and we have NHANES 3 library, right? And inside NHANES 3 library, we have adult 1. And if we look over here, we have adult 1, right? And what we're going to do with adult 1 is we're going to manipulate it. We have the SEQN variable and the DMA racer variable. And we're going to keep this variable, right? And the reason I'm a big firm believer of using the keep statement is because once I see my new results, right? For example, adult 2, I don't want to scroll all the way to the end and look for my results. I'd rather just look at 2 nice columns. So because the actual variables in adult 1, I think there's a lot of variables, right? So after the 20th or 30th variable, it starts getting very, very messy. And I like being organized because if you're dealing with about 40 or 50 data sets for an entire research study, right, it's very important to be organized. All right, so you're probably saying, well, what is DMA racer and what is SEQN, sequence N? Well, if you go back to our NHANES, right, website, a lot of data sets, or actually all data sets, should come with a data dictionary. There should be some documentation that you have to search for. That documentation is either, in this case, a PDF file or a spreadsheet. And there's about 462 pages. Please, please do not print this out. It's a huge waste of paper. What I would do is, for example, if I want to look for race, I will just do Command F, right? And let's say I want to look for a race variable, right? So notice over here, this looks like races in the exam data set, the lab data set, HA and HY. I think HA is probably adult, HY is youth, Y for youth. But let's just continue finding race, right? Here we go. So notice you have race and DMA racer. So then I'm going to take this, I'm going to copy this, and I'm going to actually see what it means. Right? And notice over here notice you have the SAS name of the variable called DM racer, right? You have the counts, right? And if you look over here, there should be in this data set 13,738 whites, right? Some data dictionaries are nice enough to actually include counts, but what's more important is this coded value. 1 means white, 2 means black, 3 means other, and 8 means Mexican American, right? So right now, if we look at this data set, right, if we look at adult 2, I don't know what this all means, right? So I like to code it in a way where I actually understand it. So we're gonna recode this using an if-then statement. So we're gonna say if DMA racer is equal to 1, then we'll say race description is equal to white. Right, and then I'll do another one. DMA racer is equal to 2, then it's equal to black. Close this. Then race description is equal to black. Now, I always like to just do it for 1 or 2 cases before I do them for the rest, because it gets you don't want to make a mistake over here and then you have to fix that mistake going all the way down. So I'm also going to keep race description because I want to see my results in race description. So when I run that, right, let's close adult 2, and notice 1 all the DM ratio that was 1, we create a new variable called white. DM ratio is 2 is black, right? So this looks pretty good, right? And if we come over here, 3 is what? We'll just do 3 and 4 together. 3 is other, and 8 is Mexican, American, okay? So I'm going to say 3 is other. Go back to your code. If DMA racer is equal to 3, then race description is equal to other. And if DMA racer is equal to, so are we saying 4? Let's just go with that final scenario. 8 is equal to Mexican American. Or of unknown race. So I'm just going to write, we'll just keep it simple, Mexican, American, right? And let me just run this. And notice over here, everything looks pretty recoded, right? And this only gives 1 to 100 rows. Let's just look at a few of them just to make sure we are kind of on the same page. Okay, good. Other is over here. I want to just see a case for Mexican American, right? Let me just sort descending. And notice it says Mex A. Looks like Mexican American. The rest of the term American got cut off. And the reason for that is because SAS defines the length of a variable based on the first value of that variable that was created. So for example, if you say race description is equal to white, right, then it's 1. Then SAS is going to say, oh, I don't know what length to make a race description, so let's make it W1, 2, 3, 4, 5. Let's make it of length 5. So everything of length 5 will stick after the 5th character. So 1, 2, 3, 4, 5. This American part gets cut off. So there are 2 solutions around that. The first solution, which I like, is to cut this and code this first because this is the longest length, right? And if I run that, notice what happens. We fix the issue, right? And notice, I'm just going to sort over here. Notice Mexican American is right over here. It's nice and good, right? The other way, if you don't want to do it in this method because it looks like it's out of order, is we can do, let's say we can do length of race description, and we can just call it, give it a $, meaning it's character, and let's give it an arbitrary length, which is 10. So it's 10 positions, right? And that should also fix it. And if we scroll right here, notice Mexican, 10 doesn't do it. So 10, 11, 12, right? Actually, let me just say 50, just in case, right? And notice right over here, if we just make it 50, notice Mexican American will also work. So that's another solution. We're going to do a little more recoding, right? We'll do it in the next video.